In example 2, we're given A and B, and A and B are sets of numbers. So A is a set of numbers for x such that x is greater than -3, and B are all numbers that are less than or equal to 5 for x. In part A, we have A union B, so this is put them together, or all of it, and this is A intersection B, so that's only where the two will intersect. So let's compare and contrast these. Let me do the first one here for you. In the first one, we want to find the union of these two, and so if we do x is greater than -3, I'm going to draw that just above here, we'll have an open circle, and that line will be pointing to the right. So that's this first one here. This is A. You can darken it in if you want, or not. The next one is x is less than or equal to 5. Oops, let me draw that here, sorry. And the thing with a union is the value has to be included in only one of them. So for instance, if you were looking at the union of the states, that would be all the states. You wouldn't want to find the intersection or where states overlap. Well, they don't overlap. So if you're thinking about that union, or that term union in another context, you can understand the union as being all the pieces put together. So this value of -3 here is not included in the first one, but it is included and does work for the second one. So we definitely want to include that. And then all these values work for the first one. All of these values work for both, so that's fine. Here we've got a filled in circle, and it also works for the other one. And then all these values work as well. The union will only have a gap or a piece missing if there are some values that don't work for both. So if the values don't work for both, you don't want to include them in your solution. But we can see here, when we find the union of these two, that the entire number line basically is filled in. Any number will work for either this one or this one. A big word that you might know would be or, if you're remembering and or statements. This is an or statement. The value just has to work for one of them. To write this in interval notation, we're going to write -infinity to infinity. This is all real numbers. -infinity is the lowest, infinity is the highest. On the right hand side, do this in a different marker maybe, we want to do the intersection of A and B. A word that you might be familiar with is and. And so if we look at this now, I'm just going to reproduce this graph here, because that's the graph of each one of these sets of numbers. But this one's going to be just a little bit different here. So there was x is greater than -3, and here we'll do x is less than or equal to 5. With this symbol, things are different. We need to find values that work for both. This piece right over here does not work for the first one, so we don't want to include it. This value actually doesn't work for the first one, so we don't want to include it. This section right here, this is where we see an intersection, or where the two meet. Another way to think about it is all these values from inside here, like 0 or -2, will work for each one. -2 is greater than -3, and -2 is less than 5. Here 5 is included in the second one and also in the first one, so we need to draw a circle here. This piece only exists for the x is greater than -3 and not for this one. So numbers out here like 7. 7 is not less than or equal to 5, so we don't want to include it. Here we totally did, because this was a union. Here we do not include values that only work for one piece, because it's an intersection, or what works for both. To represent this in interval notation, we're going to draw a parenthesis here indicating that -3 is not a possibility, and we're going to go up to and including 5.